Hi, I want to talk about what happens when we have two sources of sound that happen to be very, very close in frequency but a little bit different. So my two sound sources, one is producing a sound with an amplitude at frequency omega 1, so it's operating at A times the cosine of omega 1 times t. My second source is producing sound at a frequency omega 2, so its sound is produced at A times the cosine of omega 2 times t. So if they're both playing at the same time, I'd sum those two pieces together. Now, with cosines, there's an identity that you can use. If you add the cosine of A and the cosine of B, the cosine of A plus the cosine of B is 2 times the cosine of A minus B over 2 times the cosine of A plus B over 2. Well, writing out what I have for A and B, my sound sources would be producing a sound with 2 times the base amplitude times the cosine of omega 1 minus omega 2 over 2 times time times the cosine of omega 1 plus omega 2 over 2 times time. Now omega is 2 pi times the frequency in hertz. So I could pull out a factor of 2 pi from all of those omegas, and on the first one, I'm going to write this as 2 pi over 2, or just pi times frequency 1 minus frequency 2 times t. Now, this is a cosine function, and with a cosine function, the cosine of A equals the cosine of minus A. So I could throw an absolute value here. It doesn't matter if f1 is greater than f2, we'd still see the exact same function. Now, in the second part, 2 pi, I'm going to pull out, but I'm going to leave that over 2 there, because what that would give me is f1 plus f2 over 2. If you add two things together and divide by 2, that's the simple average. So the second piece then becomes an oscillation at a frequency that's equal to the average frequency of the two sources. What we end up over here is a shaping feature to the amplitude that's rising and falling at a frequency that we call the beat frequency. And the beat frequency is the absolute value of the difference between the two frequencies that are being played simultaneously. Now you might say, well, wait a minute, shouldn't that be the difference in frequency over 2? Well, what's happening here in terms of a wave is the envelope is rising and falling at that lower frequency, but when we hear things, we don't hear based off the phase of this, we hear based off of this intensity squared. So if we square it, we're just looking at the magnitude of the shape, and squaring a sine function doubles the effective frequency. That's why the beat frequency is f1 minus f2, or f2 minus f1, whatever the absolute value works out to be. Thanks for watching.